So, hi and welcome to a new video. Today I want to show you the data list we have implemented. That data list is simply to show large amount of data sets like multiple 100,000, 200,000, millions of entries in a data list, but only show a partial of data. Pretty much the same as Angular CDK scroll does. Maybe you ask why we are doing this by our own. It's pretty much simple because the Angular CDK with scroll has some problems, some issues with a large amount of data sets. So I don't talk with, if I say large amount of data sets, I mean something like millions of entries. So to show CDK scroll, if we find something, scrolling a material, we simply say examples, and you always see examples have, for example, let's see, what's the TypeScript code, something like this. So we have provided an array with predefined array with 100,000 items. Downside on this approach is currently, if you open operation, right, task manager. So if you open, for example, now this one, we say Google Chrome, 900 megabyte on RAM, and we open this one again when we say, okay, it's nothing much up, so 1,000 items, it's still okay. But assume we have much bigger data sets. This is 1,000 versus 1 million versus 10 million, and go. And if you do this, you can see the memory usage goes up 1.6 gigabyte. As I see created in a way. And if you expect bigger data sets like 10 million entries, hopefully it will not crash. It will even use more and more memory, and that's a big issue on the Angular CDK. For me, if you await or expect really large amount of data sets when you run always up into something like that. This is now using 4 gigabyte of RAM for free, for 7. My God, never see this before. Okay, super. Oh my God, 5 gigabyte RAM. At some point, Google Chrome will simply, it happens, it's kicked down. It was simply too much data. So Angular CDK becomes some trouble if you have big data sets. Maybe someone will say, okay, we can always provide your own data source. Yes, you can. The downside on this one, the data sources always provide, for example, always return an array. An array is the full data set. It's pretty much simple. We have now our own data source, for example. We have provide a connect method, disconnect, get page index, and the fetch page. So if the view change, so this go down, view change will be called with subscribing and getting a range, a start and an end. The start is, for example, 10,000, 5,000, whatever, some number, and then this yeah, I don't know, end number. Okay. The problem of this one is why we have to provide a full array on the bottom. Oh, so for example, if we connect, we have to provide, we return a data stream, which one can subscribe. If we change, we subscribe, we change the, we fetch a new page, we get the data, and simply say data stream next cache data. So we simply tell Angular CDK to re-render. What is the problem here? So if you set the data stream, this is a DS. Which is, I currently know it because I want to do it through the code today. Again, just to see, this is new TS connect, and the new TS is a new data source connect. You get a data stream, and we have to find a subscribe. The data stream, data subscribe. We have, for example, we subscribe to the data stream when we call if the on the data has been changed, so we get some information when we call on data on render data change. And then you see this line. This line means he will extract a partial of the array from the start index to the end index. So it means if you are in the start index of 10,000, you have a provided array with 10,000 items. And that is pretty much bad. If you will see with 10 million entries or more, I think, it simply kicked my Chrome out, and we always had to provide such a large array. So, and second thing, We have, for example, an issue is with they can use the native scroll bars. This is working because of they have the space on bottom, which has a total height of 500,000 pixels, which is calculated by, for example, with 10,000 items and 50 pixel per item, makes we 500,000. So, and now think we have 10 million entries. This is possible. And you simply go up to a size of 500 million pixels. The problem is here that we get in the past the problem that it was simply too big. This was in the Internet Explorer and Firefox. I think they both quit on the size of specific sites because the height of the element was simply too high that it couldn't render correctly anymore. Don't know, it will not be working for super large data sets. So Angular CDK is perfectly fine for smaller data amounts like 100,000 items, 200,000, maybe two. It doesn't take much memory. It's still working super great. But if you expect really large data sets, this don't work anymore. And that's the reason why we create our own data source, which simply try to avoid this one, that we don't load that large data sets anymore. And I want to show you how we do this. So see you in the technical or in the more theoretical part. Bye. So, welcome back. Some more theory now. I want to show you how this is designed. For example, we have our data source. This is the data list. For example, the data list gets a data source. This is the data source. Some texting. I need to learn to paint with my tool, but it's okay. Data source. That's the data source, and here we have our data list, for example. Data list. So, and the data list currently where's my here is it's not easy, not easy. The data list gets a data source injected. So, awaits data source, and we this is an abstract class, so we also have, for example, to extend from this one. Let's say we have one data source that is predefined, and we have a second one. I can show you quickly when. This one is which already exists, is the memory data source. It's pretty much easy, working like an array. If you can always pass an array to the data list as source, and then this array will be mapped to the memory data source. Big M looks like memory data source, with the memory data source is predefined, which is already existing. And here, for example, we create our own data source. The second one, let's say, quick example, it's the infinite data source. That's really quick. The second example we can do is a little bit more. We have a little bit more to do with, like pagination. What I showed before is the pagination that we can, for example, scroll down, open an overlay, and then scroll down, and then pick a page. Okay, but I want to show you how today how we implement this infinite data source. Yeah, this one should be implemented, and this data source is always in a view. Yeah, we can say create this one as was Fritz. So pause. Okay, the cat is back. Now we have our own view. For example, this is our app list view. This is a view we have defined. The app list view here will create a data source. In this case, the infinite data source. If we pass an array to the data list, we will automatically create a memory data source, or the data list will create a memory data source. And both of them, the infinite data source and the memory data source, are extending the data source, the abstract data source, and provide some logic and methods to show some data. See, I have to extend this a little bit more. It's the wrong one. It's like this one, and here this one at the app view adds the data source to the data list. And as a quick example, that's really fast, we can really fast do is, for example, the infinite data source. I will show you first. In the second video, we can do the gather with the pagination, which is a little bit more complex example. Not super complex, a little bit more. It's like an overlay and the data list and the data source for example, amount of numbers. So, see you back in VS Code. So welcome back to the coding example. This is a really quick example about an infinite data source. To make this work, I have, for example, now created a data page. This data page imports the TS Monkey Page Datalist module, and we have defined a component which will be show the data, and the data is currently for example, we have implemented TS Monkey Page Datalist and give him a source. As mentioned before, this is now an array, and an array will automatically convert it into a memory data source. That means we can also push an array if you want. For smaller values, it's pretty much okay. For bigger arrays like really big sites, I don't want to use it anymore. So since we only want to show, for example, 5-6 items at once, in this case now we show 4. We say display count 4, so that means we show 4 items. And this looks like this one. We have an array with 1, 2, 3, 4, 5 until 10 and show only 10 items. What we want is not to show only 10 items, we want to create a data source. And for this one, we created an infinite data source. This is a custom data source which extends the data provider. And the data provider is generic. Now we way to expect that it always return numbers. It should only return numbers. If we are extending from the data provider, we have to provide 2 methods. First one is cannot. Cannot returns a Boolean value. It means, for example, if we now on the first item and we want to go up, it's not possible anymore because we are on top. It should be not a possibility to show negative values, or if you're on bottom, it should be not the last element. It should be could put more elements because simply nothing exists anymore. But since we want to have an infinite data source, we simply say return start greater equal 0. Greater equal 0 because of the one we don't have negative values. We only show it's bigger than 0, 1, 2, 3, and then open end. Next thing, if this the data can load, it's the first check, we can load the data, it will fetch the data in it directly. And when we say here, const data, we then define array. I can say there's not an array of this one, this is a number, and return of data. We have to return observable. So we have to return observable of numbers. JHF just to fill this one. This is very easy. Let I is 0. Yes, no, it's 1. It's 1. You're starting with your 1. I is less equal than the count. This is the amount of items you want to show. In this case, it was now defined as 4. And then we say I plus plus. And we simply create a small array with 4 items. Data push. Starting with I. So we simply create a small array of 4 items and return this one as observable. Then to show this one, we have now 1, 2, 3, 4. No, because we doesn't have to implement our data source now. We have to do. So simply remove this one and simply say data source is infinite data source, right? This one. New infinite data source. We simply say it's infinite data source, and then we have to pass our data source to the data list. Display count false, okay. And then you can see we can scroll as long as we want. So just to show you the can load data again. For example, if we want to stop on the last item we could show is 100. we can say, for example, it's a start and the count should be less than or equal 100. So if it's the start index with starting with 0 and the count, this is defined as 4, this one is less than, also we can start is bigger than 0 or start and count is less or equal 100. So in this case should be 100, 99, 98, 97. Right. I can count. Cool. Okay, let's see. Quick example, quick check. And you see you can scroll, not we can't do anything anymore. We can't go up, but we can't go down anymore. And that's why can load is what tools can load. So that's just a really quick example, just to show you how we can implement it very easily. It takes me now 2 minutes or 3 minutes, really easy. In the next video, I want to show you how we can create, for example, a more better, or something better like this one. In the Datalist doesn't make any sense. For example, we have the pagination, and the pagination has we have the button. We click on this one, and then you open an overlay, and then we have simply show all the pages until 20,000. I don't want to go over now this one. Let's see, and then we simply have, for example, 20,000 items. So, but we always show only this particular amount. I mean, nobody want to do this one because 20,000 pages is a hell. It's a lot of pages, but it's possible. But this is I want to show you in the next video, and thanks for watching, and see you next time. Bye.